Hello world, Hassan here, and today we're going to be diving into one of my favorite spaces, augmented reality, with also one of my favorite products, Hololens. So in this tutorial, you'll notice that it's going to be a little bit different than some of our past ones. First of all, it's a lot bigger. You'll notice that the video is pretty long. The reason for this is that there's just a ton that we need to talk through to get started with augmented reality just from the code side. So actually what we've already done is we've posted everything we've created on GitHub. So if you want, you could just go ahead and grab what we've created, clone it, start taking it in your own direction, and let us know what you do with it, because we'd be excited to see it. The purpose of this video is more to walk you through what we've built. So instead of coding up stuff on the fly, I've actually organized a lot of the resources and boilerplate in this video, and I'll just be walking through each part so that you can understand how to build augmented reality for the HoloLens from scratch. Now, another point that I want to bring up is that you can actually follow along with this tutorial even if you don't have a HoloLens. Unity has a great emulator that you can download. I'll be talking more about that later. So just know that you don't need a HoloLens to be able to complete everything here. You can actually emulate the HoloLens on your computer. The last thing I want to talk about is what are we actually building? Well, it's going to be a simple experience where we can click and drag around a world in holographic space, and then we look at asteroids flying at the world in order to blow them up, and we'll see a particle explosion effect. Now, we won't be building all of that stylized parts on top of this in the tutorial. Instead, I'll just be going through the backbone and the architecture of the experience. But you can pull down the GitHub project if you want to see what textures we're using for the world, how we got the asteroids in, and how we did the particle effects. Again, here we're just doing an overview of the structure, how we can get the voice recognition to work, how to get gesture recognition on the HoloLens, and so on and so forth. So I'm going to show you what it looks like as viewed from the HoloLens, and then we'll dive right in and get started.
Start. Reset.
To get started, I want to point out what some great online resources are for you to use if you want to dive even deeper than this tutorial will go. So one of them is the Windows Holographic Academy. This has two sets of tutorials. One is the 100 series and the other is the 200 series. So if you want to see how Windows approaches getting started with this, or if there are more features that you want to see that we're not going over in this tutorial, this is a good place to check out. You could also leave a comment, and we'll be sure to cover what you're interested in another tutorial if there's enough interest. Another place that you can go to learn more about the holographic platform is Unity. Unity has built-in support for Windows Holographic, so if you go to the Unity manual, Platform Specific, Windows, then Windows Holographic, you'll get an overview of the platform, and this is again another great way to understand at a high level how everything is working. You can even dive into some of the nitty-gritty. But let's actually get to the meat of what we're going to start building. Now, the first step that you need to do is actually make sure that you have all of the tools installed on your computer. So at a high level, you're going to need Visual Studio, the HoloLens emulator, Unity 5.5, and Vuforia. We're actually not going to use Vuforia. We installed it anyway because it's recommended here, but I bet that you can get by with not having it. Another big point is the HoloLens emulator. Now, if you don't have a HoloLens, this is great to have because it allows you to still develop apps and in a pretty good way experience what it would be like to actually try this with a HoloLens. If you do have a HoloLens, you don't really need the emulator. Something that is really awesome that Unity does is that you can actually just hit the play button on a holographic experience and connect it to stream the experience to your headset. So you can have the headset on, hit play, look around and see all of the holograms, unhit play, do some edits, hit play again, and see those edits actually made. It's incredible. So again, this part depends on if you have a HoloLens or not. So use the HoloLens emulator if you don't have a HoloLens. But one of the downsides of it is that to use the HoloLens emulator, you actually need to have Windows 10 Pro, Enterprise, or Education. We're using Windows 10 Pro, but unfortunately, there's not a good and legal way that we know of to get that for free. We ended up paying for it, but this is something that all of you will have to decide for yourselves about, are you going to use the emulator? Are you going to buy a HoloLens? What's best for you? The HoloLens, just to throw it out there, it costs $3,000 right now, so it's not that easy to get your hands on one. But go ahead and get all of these tools installed, and then we'll dive right into building the experience. The first thing we're going to do is make it so that we can click on a hologram and move that around. That's going to be our world that we click and position before we start the actual experience. Now you'll see here that I've already gotten started with this on a Unity scene. The reason for this is that there's a lot of configuration and boilerplate, and rather than doing that on the fly, I just want to walk through it. That'll be faster, and you can also just pause the video at any time to follow along with the scripts that we've already created or to catch up with the editor side stuff. I know that this is different from how we usually do some of our videos, but again, the reason is that there's just so much boilerplate, so if you have any questions, just leave something in the comments and we'll be sure to answer. So let's get started. Again, here I have this scene and I've already configured some of it, but I'll walk through all of the configuration so that you understand every step of the way. The first thing is that we have this main camera. Now this is just the standard main camera that any scene opens with, but we've set the position to be 0, 0, 0, and we've also updated the clear flags to be solid color, and we've zeroed out what that solid color is. This is so that we have a transparent background and we're not drawing anything in the background when we see it in augmented reality. Now Microsoft also recommends changing the near clipping plane from 0.3 to 0.85, so we've done that here. And at the bottom you'll see that I've added a gesture manager to this camera, and we'll talk more about that later. But along the lines of configuration, you're also going to want to make sure that in build settings, you're using Windows Store as your platform, and that your SDK is Universal 10, the device is HoloLens, the build type is D3D, and that you have Unity C# projects checked right there. As for player settings, in other settings, make sure virtual reality is supported, and Windows Holographic is your SDK. You'll also want to go to publishing settings, and for capabilities, make sure that the microphone is checked on. That's because we're going to be using voice commands later on. The last part of configuration is in project settings and quality. You want to make sure that for Windows, you're using the fastest quality setting rather than anything else. So let's actually talk about what's in this scene. So we've discussed the main camera already a little bit, but I actually want to start by talking about the way that we're using a cursor. So I've added a cube into this scene, which you can see here, and I've scaled it down to be really small, 0.01 in all of the dimensions. And that's because we want this to be a little cursor, and again, this is a basic cube. We should remove the collider on it because this is just a UI component. We don't want it actually hitting and colliding with anything. So let's talk about how we're going to move this cursor around. So here I have the some boilerplate that I've already built out for this, and there are two big points. The first is that throughout this project we're going to be using the singleton pattern for a lot of the scripts, and that's just so that these scripts can easily communicate with each other. The singleton pattern consists of this static instance and then setting that in awake. This is just a quick and dirty, hacky implementation of it, and if you want to learn more about the singleton pattern, there's tons of resources online, but it's not important for this tutorial to go in detail. The other part of this script is the update function. Here we're doing arraycast, where when we hit an object, what we do is we store a reference to the object that we're hitting, and we also change the position of the cursor. If we don't hit an object, we null out what our focused object is, and then we draw the cursor at a fixed distance in front of wherever we're looking. So again, you can just hit pause and copy all of this if you're interested in getting all of this boilerplate, or leave any questions if you have any. So next up, let's go to the gesture manager that I talked about on the main camera. What this does is it keeps track of the different gestures that we're doing, that the HoloLens keeps track of, and it allows us to decide how we respond to those gestures. So a key point here is that to use the gesture recognizer that comes with the HoloLens, we need to be using the Unity Engine VR Windows Store Application input library or namespace, and that gives us access to this gesture recognizer component. So again, we're using the singleton pattern. We've created this gesture recognizer that we're going to use throughout the script, and we also want to keep track of when we're manipulating objects. Now there's a lot of boilerplate here, and it all starts with the awake function. So in awake, this is just standard singleton boilerplate, and we're creating a new recognizer to handle manipulation of this object. That's what's going on here. Then we're also setting it so that we can recognize a manipulation translate gesture. That's whenever we click on an object and try to drag it around. That's a manipulation translate. And with that recognizer, we actually have to say what events we want to listen to. So if you put down the recognizer variable and hit dot, you should autocomplete with all of the different events that you could listen to. The only ones that we care about are the started event, updated event, canceled, and completed. Started is when we first start moving our hand. Updated is as we keep moving it. Canceled and completed are whenever we finish. So here we're just determining on those events how are we going to respond and with what functions. In onDestroy, we need to unsubscribe from those events, and that's just common Unity event and delegate paradigm. The last part is that we need to tell the recognizer when it should start capturing gestures. So in a full-on application, we might have different recognizers for different parts of the experience. Sometimes we might want to click on a 3D hologram and move it around. Other times we might want to click on a menu and rather than move it around, actually just be able to translate our hand movements into swipes on the menu. So that's why we might have different recognizers, and we need to tell the recognizers when they should be capturing gestures and when they shouldn't be. So we'll quickly go over now what each of these events that we're calling are. So all of them have the same signature, at least for the manipulation event. So they tell us the interaction source kind, which basically determines, like, is this a controller, is it a hand, and so on. In this case, it's a hand. We also get the position that the interaction happened, and a head ray for the user's gaze. So started and updated are pretty similar. We're just checking if an object is in focus, and then we're setting manipulated to true, and either sending a start manipulation or update manipulation message to whatever that object is. So on that focused object, we're going to call either start manipulation or update manipulation, and we'll get to that later. Now for canceled or completed, we're calling manipulation ended, and this is pretty simple. We're just setting is manipulating to false. Now you'll also notice that I created a public stop manipulation function here, and that's just so that this recognizer can stop capturing gestures, because we don't want to always be able to click and drag the world around. So next up, let's talk about what's actually on this world sphere that I've created. So that's the blue one. I just have this white one as a reference point so that we can see and use it to measure that the blue one is actually moving around. So in this world script that we have are those start manipulation and update manipulation functions that I talked about inside of the gesture manager. Now what we want to do here is just keep track of where our hand was initially when we started the gesture, and that's what we do in start manipulation. And then in update manipulation, we want to get wherever our hand has moved to, which is the position that we've passed in, and then we want to get the direction and apply that direction to the object that we are clicking and dragging around. So that's what delta is doing. It's just getting the direction between the previous position and the current one. And I'm also scaling it up by 2 so that a small hand movement actually translates the object much more. And I'm actually translating the object with this plus equals on the delta. So again, that's just a quick overview there. and you can copy and paste all of this code or leave any questions or comments that you have below, and we'll be sure to respond to them. But now let's actually see this in action. So if we go to build settings, we can hit build, and I've created this app folder that I want to use, but let's just so I can show you that from scratch, if we create a new folder, you can call it app or whatever you want. I'll choose this app folder that I just created, and essentially we just want to have a folder that we're using to store our builds. So let's wait for this to get done. It takes a while for this to build out, and what we'll do is actually see this running in the HoloLens emulator. So I'll get started with that as soon as this is finished. Alright, so now a screen will pop up with that app folder that we chose. Let's open up our Visual Studio solution. And in here, what we'll want to do to get the emulator running is select Debug for the configurations, and then for platform, x86, and then in this drop-down, HoloLens emulator. Now this takes a while to actually start, but to get it started running, hit Debug, and then start debugging. And then it will start deploying the solution to a HoloLens emulator. So let's let that load up. Alright, so my HoloLens emulator has finally loaded, and to summarize how you use the emulator, if you hit enter, you can simulate a tap, which is closing your fingers like this on the HoloLens. And if you hit F2, you can bring up the menu, which is a bloom gesture, or blooming. It's essentially like a flower blooming with your hands. So let's hit F2 for that bloom. We can click and drag to look around, hit a tap on that plus sign using the enter button, and then I called my experience World Saver. So we can hit enter on that to start running our experience. Now this is simulating what it would be like to be using this HoloLens in the real world. So if we hit enter, we can tap and place a window and start running our experience. So here we see what we configured in Unity, and again I'm clicking and dragging to look around. Here's that blue world placeholder we created, and here's the white sphere that we're using as a reference point. So I'm going to hit enter to simulate a tap, and you'll see that as I move around, this sphere is moving with me. Now it's kind of hard to do this because we're just in 2D space, but hopefully you can see that as a proof of concept. Next up, I'm going to be showing the boilerplate for voice commands with the HoloLens. Now, we're going to be using this for our experience to start and reset the experience, and there are two major points of this boilerplate. First of all, we need to have a keyword recognizer that listens for our voice commands, and second, we need a dictionary that maps from those voice commands to the functions that we want to run. So let's check out the boilerplate. On the main camera, I've already attached this voice manager script. So this is going to do what I was talking about before, and we'll go through it step by step. So first of all, you should note that we're using a lot of weird namespaces here because we're using a lot of Windows platform specific functionality. So be sure that you copy those. Now next up, as I said before, we have a keyword recognizer that listens for our commands, and a dictionary that goes from strings or commands that we're going to say to these action delegates. These are the functions that we want to run when we actually say a command. You see that I'm specifying that delegate up here, and we're using that in the dictionary. So next up, we configure all of this in our start function. We're creating a dictionary that goes from different commands we'll say, such as start, to the functions that we want to run, such as send start. We also need to start up the keyword recognizer. We configure it and tell it what dictionary to use, so what mapping from commands to functions, and we need to tell it what function to run when it recognizes a phrase. So we're using this keyword recognizer on phrase recognize function. We also need to tell it to start capturing those phrases, similar to the gesture recognizer and how we had to tell it to start capturing gestures. So let's move down to what we do on this onPhrased recognize. So here it's pretty simple. We just check the keyword collection to make sure that we can actually pull out an action from the phrase that was said, and if we can get one of those actions that map to the text that we heard, then we invoke that function. So in this case, send start or send reset. So you'll see that I have those listed down here with just some debugging, logging there. And also that we're calling these functions inside of that world script that we created before. Now you notice that there's a bug here, and that's for two reasons. First of all, in the world script, before there was a little bit of a bug. We need to put a static flag on this instance for the singleton pattern to work. That's one of the problems. The other one is that we actually haven't implemented start game and reset yet. So let's actually go ahead and do those. First of all, with start game. What we want to do there, at least for now, is make it so that we can't click and drag the world around anymore. So public void start game, and to make it so we can't click and drag around, in the gesture manager we're going to call this stop manipulation event, so that our gesture recognizer stops recognizing manipulations. So that's pretty easy. We just have to get access to that instance and then call stop manipulation. Later on, when the game starts, we're also going to start spawning those asteroids. But let's complete this reset piece. And this is really simple. We're just going to reload the scene. So we need to use the Unity Engine scene management. And to reload the scene, since there's only one scene, that's as simple as just calling load scene with 0, which is the index of the first scene and our only scene. So I've popped open the experience in the emulator again, and now I'm going to show you that it works with voice recognition by showing the example of the reset command. I'm going to move the cursor away, say reset, and we'll know it works because even though I move the cursor away, the experience will reload and the cursor and sphere will be lined up. So let's see that in action. Reset. And there you have it. So let's jump on to the rest. Now let's build out the last functional piece, at least before we get into the aesthetics. It's the asteroids, and it's pretty straightforward. We're going to model these, at least gray boxing wise, with just a sphere prefab. So let's call this asteroid. We need to zero it out and also set it to be pretty small. Actually 0.01 is too small, so we'll do 0.07 on each of these. This will need a rigid body. We want to uncheck gravity, and that reminds me that on our world we want to add a rigid body too. So make sure that your world has a rigid body and it's not using gravity either. Now on this asteroid, we want to add an asteroid script that determines how it behaves. So basically we're just going to hurdle this asteroid as soon as it's spawned towards the world object. So that's the functionality that we're going to create in this script, and it just takes a few lines. First of all, we need to access the rigid body so that we can apply a force to this asteroid. So we do that using GameObject get component. And then next up, we have to find out what the target is. In this case, it's the world, and there's only one of them. So it's not the most optimal way to do it, but we can just do a find with the name of that game object, access its transform, and its position. Then next up, we actually need to apply the force. So we can do rb.addForce, and we want to get the direction towards the target from our current position, wherever this thing spawns. And let's normalize that so we can get a unit vector. And then to make sure that this thing actually flies, we can scale it up by about 10. Actually, I think 7 is a good number, but probably somewhere between 5 and 10 is what you're going to want. You should experiment with different values. So that's all we have to do for the asteroid prefab. So we have that there. And let's actually create a prefab out of that. So we can delete this one once we've dragged it into our assets area. And now we just need to modify a few other scripts to support starting the game and spawning these. So the first one that comes to mind is actually the world script. So this start game is actually not supposed to be here. That was from something I was testing. And what we want to do is in start game, we'll start the spawning there, and we'll run that as a coroutine. It's asteroid spawn, and that's going to be an I enumerator. Where every 2 seconds we'll spawn an asteroid. So the way that we do that is we need to spawn an asteroid object, which we're going to link up to this world script, and we need to give it a position and a rotation. So for the position, we can use a unit sphere and multiply that by 2 to get a unit sphere, or a sphere of size 2 actually, on the radius. So we want to make that based off, like, centered on wherever we have placed the world when we start the experience. So we're going to use transform.position plus whatever that random vector 3 that we create is. And then lastly, we want to use transform.rotation. And we're going to wait for 2 seconds between every spawn. So, yep, we're getting a error because we haven't actually linked up this asteroid object yet. So let's do that now. We create a public outlet, and then once this script updates, we can drag in our prefab to there. Now the last thing we need to do before we have all of the functionality at least stubbed out for a prototype is update that gaze manager so that when we look at one of these asteroids, it gets destroyed. We don't want to do a tap because it's really hard to be looking at something that's moving and tapping it at the same time. You could try it out if you want, or you could take my word for it. It does not work very well. So we want to make it so that as soon as we gaze at an asteroid, we destroy it. And we actually do it not in the gesture manager, but in this gaze cursor. So when this raycast works from before, what we need to do is we need to check if the object has an asteroid script component. Then we know that we're looking at an asteroid, and we can just destroy that asteroid. Otherwise, the only other object, the only other hologram, is the world. So we can set that to be our focused object. So it looks like we have a little error there because of a missing parentheses. And that is all of the basic functionality. So what I'm going to do now is actually show this working in the emulator. So now I'm going to show everything working, but really quickly I want to point out that there's one extra adjustment I made to the world script, which is we need to make it so that the player can lose and end the experience. The way I did that is that I just added an on-collision enter function, and when something hits the world, we just want to reset the experience, which just ends up reloading the scene. So let's see this working in the emulator. So we got to say our magic keyword to make the experience begin, and that keyword is start. We'll see that the asteroids begin to fly towards our world. Here they're coming, and as soon as I look at them, they disappear. So hopefully you've enjoyed this. Again, if you want to see the full fleshed out experience, just check out the GitHub that we've linked as I try to make sure that none of these asteroids actually hit the world. And thanks if you've stuck around this long. We know that it's a long video, lots of boilerplate, but in just this video, we've shown you how you can use gesture recognizers, voice recognizers, and also set up any Unity experience to work with your HoloLens. So hopefully you've enjoyed us just stubbing this out for you. You can check out the GitHub to see how we stylized it a bit more, and we hope that you take it and run with it. Also leave any comments or questions that you have, and yeah, hopefully you enjoyed this. I'm Hassan, and we'll see you around next time.